All right, welcome to 1.2 where we are going to start solving equations. Now, if you've done the review, and I please, in the module 1, doing those reviews, they are super important. We are going to see them again, and they might come back to haunt you if you didn't practice them. But for now, on a positive note, we've got 1.2 to go through, which honestly is where I'm going with this, a little bit more review than you might have expected still in this first section. So we're going to kind of go back all the way to just solving some basic algebra before we look at factors and radicals and everything else is kind of where we're at in the scope of the course. However, again, all that stuff in review is going to come back to haunt us or reward us for the studying we did earlier, and hopefully it's the latter. So let's solve some basic equations. This first equation has 8x minus 20 equals 68, and we obviously, or maybe obviously, hopefully obviously, want to get x, or the single variable, isolated or by itself. Now in this case, we would refer to this as a basic, what we call two-step equation. And here's why. Because to solve this, and remember we wrote down PEMDAS earlier in the last section, we're going to solve this using what we call reverse PEMDAS. Now here's what we mean by that. We're going to look at our variable that we want to isolate, which is x. Now we're going to look at that and we're going to say, how can I get x by itself, by asking what is happening last to it in terms of order of operations. Here's what I mean. 8 is multiplying x, because of PEMDAS, m, before a or s, and then whatever that result is being subtracted by 20. So there is multiplication, then subtraction, according to PEMDAS. So how do I get x by itself? Well, we do the reverse. Or in other words, we try to get x by itself and move everything else out of the way. Two different ways of saying the same result. Here's what we really mean. We're going to add 20 to both sides. Now also, if it's been a while, hopefully that sounds familiar. Whatever you do to the left-hand side, you do to the right. So if my left-hand side has an x and this other term that's subtracting from it, then I'm going to add it to cancel it so that I don't see it on the left anymore. And I'll write my result on the right-hand side. Okay, so I added 20 to both sides. It got rid of the negative 20 on the left. It created or produced 88 on the right. Now I just need to get x by itself. Same question, but how do I do it? Well, now there's only one operation occurring with x. X is being multiplied by 8, so I will do its opposite operation, which is division, and I'll divide by 8. Well, then I get x equals 11, and I've solved my equation. Now what I'm not going to do for sake of time is you should verify your answer by plugging 11 back into here and seeing that yes, 8 times 11 is 88. Well, I'm even just going to say it and do it. 8 times 11 is 88. 88 minus 20 is 68. 68 is what's on the other side, so yes, I must have done this correctly. So go back and check your work as often as you can, but we've got a lot more to go through, so let's see it. Up next, this one's a little interesting because we've got variables on both sides. Now this gives you a little freedom, which also makes us a little paranoid because we don't like having multiple ways, quote unquote, because we always have been told math can be done in one way. But here's what I'm going to do. I notice that I have a 6x on the left and a 5x on the right, and usually when we solve equations, our variable ends up being on the left, so why not, let's just subtract 5x from both sides. Whatever you do to the left, do to the right. Cancels here, and 6x minus 5x is a single x, 1x. Wouldn't it be nice if we all just had 1x? That's your bad joke for the day. And now we've got this equation, which is x minus 2 equals 9. All we have to do now to get x by itself is do the reverse operation that we see. Now x is being subtracted by 2, so let's add 2. And I now get x equals 11. All right, once again, we got 11. Interesting. By all means, again, and you should plug it back in to verify your result, but trust me, 11 is going to be the correct result. Up next, now is where we're stepping things up because I now see my x's that I'm trying to isolate are wrapped in parentheses and there's numbers out front of them. Well, what do we do there? We implement something we call, and you could write it on the side by name, the distributive property. Distributive property. Now, here's what the distributive property is saying. What it's saying is 4 is going to multiply at some point to x and this negative 4. 3 is going to multiply to, because when things are written next to each other in math, they multiply, this x and this 3. So let's go ahead and distribute that and essentially not say, I'll get to that later. Let's get to it now and see what we get. That's going to be 4x minus 16. And there's still a plus 18 that hasn't been touched because it was not inside the parentheses, but it still is on the left-hand side. And then there's a 3x and a 9. All right, well, what do I get now? I kind of have a problem that looks like number 2, but it's a little bit different as well. Here's what I mean. There's a negative 16 and an 18, a number and a number, or a coefficient and a number and a number, a constant and a constant is the proper term, on the same side. What do we do when we see that? Well, we just combine our constants on the same side, as is, so to speak, or as we saw them. A negative 16 and a positive 18 make positive 2. All right, let's keep going. We now really have something that looks like number 2. There's a 3x and a 4x. Let's move the 3x over to start getting x isolated. That's a single x, which again is a lucky coincidence. We haven't really had to divide for our final answer so far, but we'll get there. And, oh, we're so close, but there's a 2 and a 9. This time I have to subtract 2, so I get x equals 7 as my answer. So finally a different answer for my algebra. Once again, and I'm going to pause and do it myself. Always pause, double check your work. If you made a mistake, well, then that's an opportunity to find something, and I'm going to do that myself. All right, I took about 15 seconds or 20 seconds or so. I plugged in 7. If I plug in 7, that's 3 times 4, which is 12. 12 plus 18 is 30. And if I plug in 7 over here, 7 plus 3 is 10. 3 times 10 is 30. Hey, guess what? 30 is 30, so I know I found the right answer. Awesome, let's keep going. This one is still going to be distributive property, but it's a little tricky. There's just a negative floating out front. So what do we do with that? And also it should be said that you need to see it as just there's a 7 and a negative in front of these two terms. And so what are we doing here? Well, we're distributing a negative 1 to these two terms. The 7 is still out front. That's not being touched or affected yet. And there's now a negative 1 multiplying to 2x and a negative 1 multiplying to negative 5, which will double negate and create positive 5. Maybe you remember that sometimes we double negate and make a positive. And there's still an 18 on the other side. Well, where does that get us? Well, I now, again, have some same side like terms, so let's combine those as is, so to speak. A 7 and a 5 will make 12. Now, it doesn't matter whether you write the negative 2x first or the 12 first. What matters is that the 2x is negative and that the 12 is positive as we're going through that. Up next, now I will subtract the 12, and I'm going to start being, as I call it, a lazy mathematician, and not write out the full subtraction, but rather just show the result. All right, so we subtracted 12 from both sides, and then I'm going to divide both sides by negative 2. I guess I'll write that out because we haven't seen that much. I divided by a negative, which doesn't matter for regular equal signs, and I got negative 3 for my result. Again, plug in, plug in, plug in, verify, verify, verify. I'm looking that over in my head right now, and it works. Okay, we now get to a pretty tricky question. There's two pretty tricky questions, and we're close to being done with this section, but these two are going to take some time. Here's why. Well, there's fractions. And no one likes fractions. We don't want to deal with them. But unfortunately, you're in college algebra, and so we can't avoid fractions forever. Now, I've got a great trick or good idea that'll help you eliminate fractions in step 1, but you have to be careful, careful, careful. And the answer is, or the trick is, using what we call the LCD. So if you made some room on the side, LCD stands for least common denominator. Now, I'm not going to define it. I think it's something you'll more so understand out of practice. But when you look at 8 and you look at 7, what we mean by LCD is what number can 8 and 7 both go cleanly into? And when I say go into, I mean divide into. So what number can 8 and 7 both divide cleanly into? Now, the implication of that, or what's implied by that, is that that number might be the same size or likely bigger than either one of those. And so, again, it's something you'll get out of practice and time readjusting to your math life. The answer is 56. Now, in this case, it is a little bit of a coincidence because 56 happens to be 8 times 7. But 8 can divide cleanly into 56. 7 can divide cleanly into 56. I don't have time to show you why, but trust me, there is no other positive number smaller than 56 that 8 and 7 can both go into. Now, again, there are larger numbers that 8 and 7 could go into, but that's why it's called the least common denominator. This is the smallest number that suffices that 8 and 7 can both go into. Now, what are we going to do with this LCD? Great question. We are going to distribute it to both sides carefully. And so there's me writing that out. So what I've done here is I'm showing that I'm going to multiply the entire left-hand side, it's wrapped in parentheses, the entire right-hand side, it's wrapped in parentheses, by 56, and namely, again, 56 over 1. So I'm not multiplying it by, and this you might be confused or remember or know why, I'm not multiplying this by 56 over 56. I'm multiplying it by 56 on the left and 56 on the right. Now, we will talk later in the course of why I'm doing that, but for now I need you to trust me that I looked at my denominators. I saw 8 and 7. I figured out what's the number that both of them can go into. 56 is the smallest. My least smallest common, they both can go into. Denominator, out of both denominators, happened to be 56, and I notice I put it in the numerator. Now, you're going to need to take your calculator out or learn to do some quick mental math. I'm going to describe it mentally, but you need to hear it verbally and trust that you can plug this into your calculator. That 56 times 3 over 8 by PEMDAS, notice I've got my multiplication and division underlined, hear this, is the same as saying, what's 56 divided by 8? I can do division first here, and that's 7. And 7 times the remaining 3x is 21x. So there's my simplified left-hand side. Now let's keep going, and I've got to use the distributive property here, kind of written backwards, but it works the same way. 56 over 7 is 8, and 8 times the leftover 6 is 48. Now again, also don't mishear me. By all means, take your calculator and type 6 divided by 7 equals blah, 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 and then times 56, and trust me, you'll see 48 spit out. If not, you need to double check how you plugged it in. And finally, what is negative 27 times 56? Now this is finally where I need a calculator. And I get a whopping negative 1,512. Goodness. All right. We're running out of little space. We'll put a line here and continue on down. Now I've got a 21 and a 48, and I'm trying to get x by itself. And so again, by the easiest way to say it is by typical math pattern, we usually put our x on the left. So let's subtract 48 to both sides. What will that give me? That'll give me negative 27x equals negative 1512. So again, in that last step, all I did was I subtracted 48 from both sides. Well, it canceled on the right, and it became negative 27 on the left. And finally, let's divide by negative 27. And that will double negate and actually coincidentally get me 56. And that should be my answer. Now this one's a little harder to plug and verify, but you still should be able to. If I plug 56 in, that is 7, that is 21, so it's still 21, kind of coincidental. So 21 is what I have over here. If I plug in 56 and divide it by 7, that is 8. 6 times 8 is 48. 48 minus 27 is 21. Great, I got 21, 21. That is kind of a coincidence that we saw the answer earlier in the math and we said it out loud in our work along the way. But hey, guess what? I know I got the right answer because I was able to plug it in and work it out by PEMDAS. Now the next one, this is your kind of challenge question. So this would be where I would say, pause the video, try it out, and see what you can do. Be careful of the order of operations and where your denominators are and how they distribute. This is kind of still a trick question, but it's good to kind of sit and try it. Now we're going to jump into how you solve it. Well, my denominators are 2 and 5, which makes by LCD, hopefully we at least thought about that and figured it out, 10. 10 is what 2 can go in cleanly to and 5 can go in cleanly to. And so we're going to distribute 10 to all sides. Now I'm going to write that out and then careful how I say it actually takes effect. All right. Now for the 10 over 2 times x, that should be 5x because the 10 and 2 reduced to 5 and the x is left over, so it multiplies after. Now watch this. There's a 10 times this 1 out front entirely. That's just 10. Now this is a little bit of a leap, but this 10 over 5 becomes 2, so 2 is multiplying to x, and 2 is multiplying to negative 20, and that gives me negative 40. Now that is, again, probably the biggest leap of the lectures we've had so far, is that this 10, when it goes over 5, reduces to 2 entirely, but that 2 left over still goes to x and still goes to 20. After that, and again, really sit, think, try, rewatch, whatever you need to do, that's a hard concept. There are other ways to look through this problem, but I really think this is the easiest way if you can figure it out and grasp it and get a hold of that. After that, we're in pretty smooth sailing territory. I'm going to do a few things as I clean up here. Number one, I see some similar like terms on the left, so let's deal with those. There's a 2x but a negative 30. There's then a 2x which I need to move over, which will be 3x. And there's then a negative 30. And I can just divide both sides by 3 and get negative 10. And I can cross-check that that works by plugging it back into the original. And you're going to need to trust me that I did plug it in, but I did mentally, and it does indeed work. Now, there are a few special cases that we need to be considerate of. There's what we call conditional equations, and what I'm going to say is conditional equations are all of the above, or in other words, one exact solution. So notice in all the problems above, we got x equals 11, 11, or 7, or negative 3, or 10, or 56. But it was one single answer. So those are what we call conditional equations. Now there are identity equations. These are special where you end up getting 5 equals 5, which is what we call always true. And that's what makes it an identity, is that the algebra ends up disappearing and you end up getting a weird answer like 5 equals 5, and so you're good to go. And finally, there's inconsistent, which would be an example where maybe you get something like negative 2 equals 48, and that's never true. And that's a mathematician's way of saying inconsistent. So let's see what one of these might look like. We don't know which one this is, but let's work one example out real quickly. Well, we've got some distributive property to do. That's 2x plus 4 equals 8 plus 2x. Now from there, how would I get x to one side? Well, I would need to subtract 2x from the right to move it over. Now this is where things get wacky, because as I subtract it to move it over, it simultaneously cancels out on the right, and I get something like this. I get 4 equals 8. Now that's never true, and so this was an example of an inconsistent equation. This equation is never true. There's no answer I can plug in to make this work, and I can see that because this equation again simplifies to 4 is 8, and we know that 4 is never 8, so this must not be true. Now look out in your homework for an example where maybe this algebra works out and you get 7 equals 7, and then you would say it's always true. There's infinitely many solutions. All right, I'll see you on the next one.